In the present video, we're going to continue talking about algebra using Maxima. And specifically, we're going to address two subjects here: first-degree fractionary equations and inequalities. So let's get started. We have this worksheet to work with. A first-degree fractionary equation is one that has fractions as coefficients. There's nothing special about them. You can use solve and you get the result. Here's another example. With solve, we get the results. This is our first order. This is a more complicated equation. And you can still use solve to find it. First degree equation with composite denominators, something like that. Let's try solve EQ and you get the result. Solve would be the way to go here. You can do the simplifications in here, multiplying things out, dividing, moving things around. But if you want a quick result, simply do solve. Here's another question with a little bit of complications here in the denominator and give you that result. Literal equations, the first order. In this case, x is the unknown, but we have b and a explicitly expressed in there. So b disappears and x becomes a minus 1 over 2. Here's another one involving x and m. The solution of that, x equal to 2m. Here's another one. The solution is given by 2ab divided by 2a minus 2. Where problems b is h, x is 3/5 of h. So if x is less h and y is going to be 3/5 of x. And if both h's are added together, the sum exceeds by 4 years h doubled. Okay, so you have to add 4 to twice the h of y to equate the sum of the two terms. So we have two equations here. One that says y equals 3/5 of x, and the other one x plus y equal to y plus 4x. So if I do substitute y equals 3/5 of x into this right equation, I get an equation in x. If I solve for x, that will be solving for the h of a. And then y will be 3/5 of that, which is 6. The length of a box, which is 800 feet, except in 744 feet, the 8/9 of the width. X equal width, 800 equals 7/4 plus 8/9 of fifth. So if we do solve here, we get x equals 63. To check, multiply those terms, you get that result. In this video, we discussed also inequalities, and an inequality will be an expression like this where there is a variable, an unknown variable x, but it is not, the two sides of the inequality are not related by an equal sign, but by a less than or a greater than sign. Let's look what the inequality will look like. Now, to handle inequalities, I invite you to pause this video and read this paragraph about the rules that govern inequalities. We're going to be using them in solving for the inequalities. Read them, pause the video, or read them in your document, and then we'll continue. Well, we have this inequality, and we want to find what ranges of values of x will satisfy the inequality. What I'm going to do, I'm going to subtract 5x over 3 from both sides, and I have to do it this way. I'm going to replace the inequality with the left-hand side of the inequality minus 5x over 3 greater than the right-hand side of the inequality minus 5x over 3. I'm assuming we're subtracting the same quantity. The direction of the inequality remains, and I get this result. Now I want to get rid of that 7, so I'm going to subtract 7 from each side, ending up with this result. Now if I multiply by minus 6 over 13, I'm going to isolate the x in the left-hand side. But multiplying by a negative value requires me to change the direction of the inequality. So if there's greater than, it's going to be less than in here. And the result is x less than 6. So any number less than 6 will satisfy the original inequality. This is the inequality we started with. And I'm going to take a value of x equals 4, which is less than 6, and check that the result of this inequality replacing x equals 4 is that 5 is greater than 2/3. And that is correct. 5 is indeed greater than 2/3. If we want to look at that with the floating point, we have 5 greater than 0.6. All right, in the second example, we're going to have some quadratic results, but when we expand the left-hand side and the right-hand side with conserving the direction of the inequality, we find that we have x squared on both sides, and that's going to simplify things. So we subtract x squared minus 24 from both sides, then the x squared disappears, and that makes things easier. Then the next step is to subtract x, so we leave a 0 on the left-hand side. And then I'm going to switch the sides, switch in the direction of the inequality, and add 4 to isolate 8x, divide both sides of the inequality by 8, and I get the result x greater than 1/2. I'm going to check here the original inequality. I'm going to copy it and insert it right here, because I want to take a value greater than 1/2, let's say 2, and say if we substitute x equal to into the inequality, oh, subs t with the t there, and we have 2 greater than 1/2, which is true. So this is the solution for the inequality that we started with. Let's try this next one, which has a fractionary with an x in the denominator. So in order to eliminate that x, I need to multiply by x, but I need to make an assumption. I'm going to assume that x is greater than 0. If I assume that x is greater than 0, then I'm going to conserve the direction of the inequality. So I multiply by x and I get this result. When I eliminate the denominator, finding the minimum, the least common multiple, which is 6, so I'm going to multiply by 6 both sides, expand, and then I want to keep the x squared on the right hand side. I'm going to subtract 2x plus 6 from both sides and switch the direction of the inequality and get this result. So the left hand side is a quadratic equation, and I can use solve. I'm going to put the result in a big X, and I found that my values of x are the square root of 19 plus 1 over 3, or the negative of that value. Oh, actually, no, actually minus square root of 19 plus 1 over 3. So it's not exactly the negative of the other value, it's just the result of the quadratic equation, but these are the roots. This value and these two values I'm going to call x1 is this one, the first one, and x2 the second one. x1 right here, x2 right here. Because after having solved that equation using solve, we're going to learn more details on how to solve quadratic equations later on, but at this point we're going to rely on the factoring. It turns out that we can write the inequality this way, and I'm going to call that my equation 1. So this is true if this is positive and this is negative, which means this. Okay, using float, that means x greater than negative 1.11 and x less than 1.78. So what is common for these two cases? X will be actually the range contained within those two values, greater than the left one, less than the right one. To satisfy the original assumption that x must be greater than 0, then we need to reduce this range from 0 to x2. Negative values will not be considered because they violate the assumption that x is greater than 0. So currently I have this range as satisfying my inequality. Equation 1 is also true if the first one is negative and the second one is positive, which means x less than 1.15 and x greater than 1.78. These are ranges that are in completely opposite sides. They have no common element, and therefore nothing can be gathered out of this. So we have this result only so far. But now the original inequality can also be multiplied by x with x less than 0. If we do that, we're going to have to change the direction of the inequality, and we did here. Then multiply both by 6. Simplify in a similar manner that we did before. We find now the quadratic terms that can be decomposed like this, greater than 0, and that means both of them have to be greater than 0, or both have to be less than 0. With both greater than 0, we find that this satisfies the it's a common range. Now, but we have to keep in mind that we have assumed x less than 0 in order to simplify the equation. And so the common result right here will be given by x greater than x2, but x2 is positive. So if x2 is positive, then you cannot satisfy the x less than 0, and so there's no result coming out of this analysis. But if both of them are negative, then you have that this will satisfy the common requirement, and this is actually less than 0, so this will be the other part of the solution. In summary, the inequality that we started with has the solution these, and in other words, less than these, or between 0 and these. In terms of floating point values, we'll be saying that x has to be less than minus 1.1196, or be between 0 and 1.786. We're going to check with values of minus 2 and 1.5, which are values that are contained between those values. Redefine the inequality. Substitute. Minus 1 is indeed greater than minus 6, so that's fine. Substitute here. 1 is greater than 0.75. That's correct. These two values are outside of the range of solution. Minus 4 is not greater than minus 3, so this is false, and also this case. Now, the last example turned into a quadratic, and the quadratic turned into a detailed description of the inequalities. And we haven't yet talked about quadratic equations, so I owe you that one. Well, I just wanted to show you how to solve inequalities, and with that we finish this video about fractionary equations and inequalities.